I wanted to give a quick update of the status of the basic interpreter for the C256 Foenix. Since the Revision C board is, as far as I understand it, getting fairly close to completion, I've gone back in and I started adding some graphics commands. And I wanted to run through some examples of those today and give you a quick demonstration of what the basic interpreter can do with the graphics. Before I get into the actual graphics commands, I want to let you know the syntax you're going to see here is not set in stone. The actual names of the commands, the actual layout of the parameters, and so on. If you have concerns about any of that stuff that you see, you have feedback from me about it, feel free to put the comments down below, and I'll take that feedback into consideration as I finalize the interpreter. So let's go ahead and get into the commands. At the top level, there are really three commands that I think of as kind of general purpose graphics commands that are used independent of what modes you're working with graphics engines. We have graphics, set border, and set color. Graphics is the master control, essentially. So the Viki chip has a central control register, the master control register, that controls which of the different graphics engines are currently turned on the Viki chip. You, generally speaking, don't want to have Viki doing everything unless you really need to be doing everything. If you don't need sprites for your program, generally speaking, you don't want the sprite engine turned on because it can potentially take cycles away from memory access. So the master control register lets you turn on and off the different engines as you need them. And all the graphics command does is to take a byte value, so from 0 to 255, and turn on and off the appropriate bits in the master control register. And you see here in this table, I've listed out the different bits that are in the Viki master control register. Going from right to left, we have text, which turns on and off the text engine, so the kind of the classic text display. Text overlay that lets you use the text engine and the graphics engine at the same time, just layering the text over the graphics. Bit 2 is the graphics engine master control bit. So if you want to do anything with sprites, tiles, or the bitmap display, you need to have the graphics bit enabled. Bit 3 is the classic bitmap display. That's the individually addressable pixels. Bit 4 turns on the tile engine. So you have 4 different tile maps that you can work with in Viki, where they work sort of like the text display, except that instead of text characters, you've got individually definable tiles that you can create in a graphics engine. Bit 5 turns on the sprite engine, so those are the classic 32 pixel by 32 pixel sprites you can move around on the screen however you like. Bit 6 is turning on the gamma correction engine that the Viki chip has, so you can tweak the color rendition on the screen. And then bit 7 is a global disable for the Viki chip. If for some reason you need to turn Viki off for some operation. So anytime you're going to want in a basic program to change how the graphics are being displayed, you're going to use this graphics command. Next we have set border. As you might remember, the typical boot up screen of the C256 Foenix, you've got a little border around the screen. That's actually reducing the amount of text that you can display on the screen at one time. You may or may not want that border there, or you may want to change the color. Set border lets you change that. A required parameter there is visible, which is simply a numeric value. If it's 0, the border is not displayed. If it's any other value, the border will be displayed. Optionally, you can provide the red, green, and blue components for the color that you want the border to have. And those components are values from 0 to 255. That will be the same in the next command, which is set color. The color model for the 256 Foenix is an index color scheme. So there are, I believe it's 10 different color lookup tables that are palettes, essentially. You have 2 small palettes for the text mode, where you can have, I think it's 16 colors in each palette, 1 for the foreground color and 1 for the background color. And then you have 8 color lookup tables for the different graphics modes. So sprites, tiles, and the bitmap can all be set up to use an individual color lookup table. And each of those color lookup tables can contain 256 different colors and In all cases, those colors are defined with an individual red, green, and blue component. So for example, I can say color lookup table number 0, color number 5 should be gray, for instance, and have 128, 128, 128 for the red, green, and blue components. And I'll show you an example of that in one of the demos. Next up, we have what I'm currently calling pixel map graphics. These are the bitmap graphics. I'm calling it pixmap because it's not really bitmapping in that it's not black and white, where an individual bit corresponds to an individual pixel. These are pixel maps where each pixel is a byte in memory, and that byte is specifying the color that that byte should have. So the pixmap has a color lookup table associated with it, and the way we can define this is with this first command here, pixmap. This lets us control whether or not it's visible, and visible is again either 0 or some other numeric value. If it's 0, the pixmap is not visible. If it's 1, it is visible. This does not turn on and off the bitmap engine. This is simply controlling the visibility of the pixmap. So if you need to turn it off briefly for some purpose and then bring it back, that's how you can do it. The other required parameter here is a color lookup table number. That is one of those, you put in the number of one of those 8 color lookup tables that are provided for the graphics engines, and that is going to specify what a particular byte value for the pixel, what color that corresponds to. So when Vicky is going and displaying a pixel, it looks up the value in the pixmap. It gets a numeric value from 0 to 255. It goes to the associated color lookup table for the pixmap, finds the RGB components for that, and that's the color that gets displayed. So this is where you can control which lookup table is used. As an optional parameter, you can also provide the address in the video RAM where you want the pixmap data to be pulled from. If that's not provided, it will default to the very first byte of the video RAM, which is currently on the RevB board, that's at B00000 hex. But you can put it anywhere in that video memory so long as there's room. It must be in that video RAM, however, so you can't set an address of 0, for example, because that's in the system RAM that Vicky can't see. The next command here is clear pixmap. That just clears out the pixmap, sets all those pixel values to 0. Then you have a plot command. You give it X and Y and a color value, and it just draws a dot with that color. You get a fairly traditional line command where you give it an X0, Y0 coordinate, an X1, Y1 coordinate, and a color value, and it draws a line in that color. And then you have a fill command with the same sort of parameters that you define the corners of a rectangle, and it will fill that rectangle with that color. One thing that's kind of fun, I think, with the fill command is that Vicky provides a video DMA command. And one of the things that it can do is that it can fill a portion of video memory with the pixel value. And it does it very quickly, much faster than the CPU can do it. And the fill command uses VDMA for its filling operation, so it's quite fast. Next, we have the sprite commands. So sprites in the C256 are a lot like sprites on other older systems. A sprite in Foenix is a 32-bit by 32-bit square, or rather 32 pixel by 32 pixel square. Those pixels, again, each one is a byte value that is specifying a color that you want to have at that location. So every sprite can have 256 colors in it. That sprite can be located anywhere on the screen, or it can be invisible. And sprites can also have layering. So a sprite can be in front of another sprite if they happen to cross. So these commands here let you specify all that information. First one here, the sprite command, you give it a sprite number, and for that sprite you give it a lookup table that you want it to use for resolving its colors. And that means that you can have multiple sprites on the screen using different color lookup tables. So if you have a set of palettes, for example, for moving scenery in a game, that can be one color lookup table. If you have another set of colors you want to be using for your game character, For your protagonist, that could be a completely different color lookup table. So you can have, with the sprites, you can have, 1,000 colors on the screen with the sprites if you want to, using different color lookup tables. The third parameter here on the sprite command is an address. That is, again, like with the pixmap, that is the address in the video memory where you want to have that sprite data located. The next command here, sprite at, that's just setting the X and Y coordinate of the sprite where you want it to be displayed. And the final command here is sprite show, where you give it a sprite number, a visible value. Again, that's a 0 or any other value. If it's 0, the sprite is not displayed. If it's any other value, it is displayed. And then optionally, you can specify what the priority layer for that sprite is. I could have put the layer parameter up in the sprite command and have that be something that you just define when you define the rest of the sprite. But I thought it might be useful to have that as part of show so that you can move a sprite from layer to layer and control which things are displaying in front of other things without having to go back and redefine the sprite. And that's really it for the commands. So first of all, let's get into a demo where we'll draw some lines on the screen and show the basic commands in operation. All right, here's the first program. This will just demonstrate some line drawing. And I'll do a little quick walkthrough to show you what these different commands are doing. So we start off here in line 20 with the graphics command. This is turning on the lower 4 bits of the Wiki master control register. So that's going to turn on graphics, bitmap, the text overlay, and the text engine all at the same time. So we'll show text as well as the graphics. Line 30 here is turning on the display of the actual pixmap. And I am not providing the address because I'm just going to use the default for this particular demo. In general, you'll probably want to provide a specific address. Certainly, if you're going to do page flipping between bitmaps, you would provide the address here in the pixmap command. 40, we're just clearing the text screen. 50, we're clearing out the pixmap display and blanking that. Then we're going to set up some variables here. We're going to draw a figure, and I'm controlling what are the left and right and top and bottom extents of the figure. And I'm going to go through a loop here and draw 2 lines per iteration from one coordinate to another. And that will do the actual drawing of the figure. And then once we're done with that, we're going to go through here and do this set color command, and we're going to set a gradient on the colors that we're using, going from blue up to full-on red. So for a particular color number, so we're going to fill all, we're going to set all 256 colors. We're going to have the color number be the same as the red component. We're going to provide no green component. And then the blue component is going to start off at 255, and as the color number increases to 255, the blue component is going to drop down to 0. So that should go from full-on blue to full-on red. So let's go ahead and give this a try. And there you see, nice little figure there. Just for fun, let's break out and go to the interpreter, and I can give a little example of filling a block with something. So here's the fill command. Let's go, I don't know, 50-50 for the upper left-hand corner, maybe 150-200 for the lower right corner, and for the color value, let's do something like right in the middle at 128. And there you go. And you can see how fast that was. Let's do another one here, maybe color 5. And that's fast because it's using that Wiki. It's fast because it's using the VDMA instruction that's in the Wiki chip, which is going and filling that video memory as fast as the Vicky chip can do, which I don't know what the clock speed is on Vicky, but it's quite a bit faster than the CPU is. All right, so that's a quick little demo there. Let's go and check out something else. And now let's do a demonstration showing how sprites can work in the basic interpreter. So for this demo, we're going to put a little sprite on the screen and make it bounce around. And so we'll show off here some of the sprite commands. Again, we're going to start off in line 10 with the graphics command, but a different mode value. So we're not going to use the pixmap here, instead we're going to use the sprite engine. So instead of 0f, which is what I had before, I've got here 27. So that 2 in the high nibble, that is the enable bit for the sprite engine. And then the 7, the 3 lower bits there, those are turning on text, text overlay, and the graphics engine. Next we come to the sprite command. So this is where I'm defining sprite 0, and I'm saying sprite 0 is using color lookup table 0, and its pixmap is going to be at B10000. So that's really I think the second bank of the video memory. I didn't have to use that particular location. I can use whatever location in video RAM I like, so long as it's not too close to the end and we don't have enough room for all the pixels. But I just picked this one at random. Line 30 here, I'm turning on the sprite, so I'm letting you see it. And, depending on the settings in the Vicky chip, you might come up with some random junk in there. This is probably not how you'd want to do things in an actual program, but this is just a quick little demonstration. But now I do need to set up what the values are for all the pixels in the sprite and what the colors should be. And so I'm going to do that here in these 2 nested for loops. I've got 2 parameters, or 2 variables, v and u. V is going to be the row number and u is going to be the column number. And I just want to do a gradient fill of the sprite where each row is a particular color. And so what I'm going to do is I'll poke into that address in the video memory, starting from the very first pixel. I'm going to multiply the row number by 32 and add on the column number to get the offset within the pixmap of the pixel that I'm setting. And I'm just going to set its value to V, which is the row number. But I need to say what color corresponds to V. And I do that here with a set color command. So there is the V index, color index. And for the red value, I'm going to take V and multiply it by 7. So when V is all the way to the top, when we're there at row 31, that'll be full on red, and blue will be 0. And at the top of the top of the sprite, when V is 0, we're going to have no red, and we're going to have 100% blue. Now that I've defined the sprite and I'm displaying it, now I need to set its location. And this is just going to iterate through. We're going to have X and Y. We've got X and Y values for the sprite, and delta X, delta Y, which is saying which direction it's going to go in. We'll display the sprite here. So there's the sprite command to display the sprite at a particular location. We're going to start at 32, 32. Then we're going to add on the deltas. And then we're going to check to see if we're hitting the boundary of the screen. I'm using these values here so that it bumps into the border and bounces off the border. If X is at the boundaries, then we'll switch the value of dx. If Y is at the boundary, we switch the value of dy. We'll do a little delay loop here to slow the sprite down, and then we go back to 110 and move the sprite again. So let's give that a shot. And there we go. Bounce, bounce, bounce. If only I had sound working. We'll get sound commands eventually. You probably noticed that the sprite appeared in the middle of the screen at the start of the run of the program. That's because I tested this program before I recorded this. And so Vicky, the Vicky registers already had a value in them. I hope you found those demonstrations interesting, and they whet your appetite for what the C256 Foenix will be able to do and what you'll be able to do with BASIC. And thanks for watching.